taking place in the first, let's say, 10, 20 centimeters of soils. And you don't see it, but it's still flowing quickly. And therefore, if it is quick, it's runoff. If it is very slow, it's storage. So we call them rainfall runoff models. And in order to build these models, we need to describe how water flows, either over the ground or in the form of hyporheic flow. I'm not sure if my pronunciation of hyporheic is correct. I hope you understood. It's written in this way. If you go to Wikipedia, there is for sure a page describing it. So we need to describe this flow. And it's flowing water. So it's a flowing body. It's a moving body. And therefore, what kind of laws physical laws can we use in order to describe the movement of a body? The moving of a fluid, which is formed by moving particles. Of course, we can call into play Newton's laws in order to describe it's a classical mechanical problem, in particular fluid mechanics. And mechanics is based on the application of Newton's laws. And the Newton's laws can be something that may look obscure to you, but let's say, in order to be clearer, much clearer, that Newton's laws imply conservation of mass, conservation of momentum, and conservation of energy. So we just have to impose these conservation laws, and we describe the movement of water. Conservation of mass, again, conservation of energy, and conservation of momentum. Let's say that the basic laws are conservation of mass and conservation of momentum. Momentum in Italian is quantità di moto, and conservation of momentum under certain condition implies conservation of energy. And that's it. It's very simple. It is the problem is to identify the domain where we have to impose these conservation laws. This is the real problem. Not really the conservation laws. They are very simple. I mean, of course, they may look not simple because we are not mathematicians. So to our eyes, they may look not simple. But I can for sure tell you that indeed their application, at least it's simple, and also the concept is simple. What is complicated is to define the domain. So where should I apply these conservation laws? Of course, to a volume. And here I go back to the concept of control volume. The control volume is the volume in the space that can be fixed or moving, where I need to apply the conservation laws. It's difficult to identify it. For a river, it's relatively simple, because you see, you can survey the river, but still, think of a river. How much complicated a river is. Because if I have to define this volume where I want to apply laws, physical laws, I need to survey it, of course. I need to define the geometry of the volume. So I cannot just say the river. I need to define the region in the space occupied by the river, which means surveying the geometry of the river. And think of how much a river is complicated. You can ask a surveyor to take a survey of a river cross-section. But then, if you move downstream or upstream 1 meter, the geometry is completely changed. So it's a very complex system, even if it is very easy to see it. Think about hyporheic flow or a groundwater aquifer. How can I define the geometry? I mean, it's not observable, how can I describe the pores that you saw before, or the fractures in an aquifer? How can I survey them? This is the real complication. When we want to model the water flow in a natural system, let's forget about pipes. This is very easy. Water supply system is made by pipes, junctions, very easy to define them. But when we talk of a natural system, this is the real complication of defining water flow in natural systems. This is why we always talk about uncertainty in water resources assessment, uncertainty in water resources management, because even if we perfectly knew the physical processes, it's impossible to precisely define the geometry of the control volume, the geometry of the system, the geometry of a river, the geometry of an aquifer. This is the real problem. Not to speak that when you take observation, there is always uncertainty. So when I measure the river flow, when I measure rainfall, there is always uncertainty. So there are many sources of uncertainty which are the real complication, even if they are very easy to understand. It's very easy to explain that it's impossible to define the geometry of a river precisely. But this is the real challenge from a technical point of view. The physical laws, okay, you may require to study a little bit to understand them, but it's not really the problem. Okay, let's take a coffee, 15 minutes break.